A flicker of radio static crackles across the dark as a signal pulses faintly through the control room's speakers, steady, rhythmic, unnerving in its perfection. Somewhere, light years beyond this small cluster of machines and wires, a neutron star is spinning. Its radiation sweeps across space like a cosmic metronome. The instruments do not tremble. The screens do not blink. But something ancient is knocking. The night sky you remember from childhood, the one that soothed you, terrified you, whispered of unreachable infinities, was never truly silent. Silence is a construct of air and eardrums. In the vacuum of space, where sound as we know it cannot travel, the cosmos still sings. Its voice is a mosaic of frequencies, pulses, and flares, stitched across the electromagnetic spectrum. These aren't just metaphors, they are literal, recordable signals. We are surrounded by a symphony that began long before we existed to notice. Radio telescopes stretch their arms across deserts and mountaintops, pointed toward black voids brimming with memory. They collect the emissions of pulsars, city-sized remnants of dead stars that spin with millisecond precision. Their clockwork regularity surpasses even our finest atomic standards. These celestial lighthouses beam radiation across the cosmos, not out of intent, but as a byproduct of their magnetic frenzy and angular momentum. Each tick is a remnant of collapse, a whisper of the violence that created them. Elsewhere, less orderly murmurs emerge from quasars' galactic cores powered by supermassive black holes consuming matter at incomprehensible rates. Quasars scream into the abyss across billions of light years, their light having traveled since the universe was a fraction of its current age. These signals, flickering, often erratic, contain the fingerprints of early cosmic history. They are time capsules lit by gravitational hunger. Even interstellar gas clouds speak, though their tone is gentler. Hydrogen, the universe's most abundant element, emits radio waves at a frequency of 1/420 megahertz, the famous 21-centimeter line. When tuned precisely, our instruments can map entire galactic structures, detecting rotating arms of galaxies, the ebb and flow of matter, and the places where stars are being quietly born. Our own star is part of this polyphonic web. Solar flares hurl particles into space, disrupting satellites and tracing auroras across our poles. To the instruments that listen, these events are cacophonous, loud and sudden, contrasting sharply with the cool regularity of a pulsar's beat or the patient drone of microwave background radiation. The cosmic microwave background, a nearly uniform glow in all directions, is the echo of creation itself. This radiation is not an afterthought. It is the residual heat from the Big Bang, redshifted and cooled over 13.8 billion years into a whispering bath that permeates all space. It speaks of the moment when the universe transitioned from opaque plasma to transparent expansion. In its subtle anisotropies, tiny variations in temperature, we detect the seeds of structure, the origin of galaxies, of stars, of us. And yet, even this deafening chorus accounts for only a sliver of what the universe truly is. 5%. Just 5% of the cosmos is composed of the matter we can see, measure, and name. The rest is shadow, inferred not from direct detection, but from gravity's stubborn insistence that something is missing. Dark matter, the unseen scaffold of the universe, holds galaxies together like invisible sinew. Without it, spiral galaxies would fly apart. It has no known charge, reflects no light, interacts with no force except gravity. And yet, its presence is undeniable. Vera Rubin first noticed the anomaly when she charted the rotation curves of galaxies. Stars at the edges moved too quickly, far faster than Newtonian physics allowed, as though led in a dance by a partner who could not be seen or touched. That dance, that gravitational grip, became one of the defining riddles of modern astrophysics. Rubin's work revealed the ghost within the cosmic machinery: gravitational lensing. Another piece of the puzzle shows us how light bends more than it should as it passes massive galaxy clusters. The light's path is curved, suggesting hidden mass pulling on space itself. Dark matter, it seems, acts like a transparent lens, warping the very geometry of reality. It's not just what's there, it's what determines how things move, how light travels, how structures persist across time. Some speculate that dark matter might be composed of WIMPs, weakly interacting massive particles that pass through our bodies every second, utterly unnoticed. Others propose actions, hypothetical particles so light and elusive they skirt the boundaries of quantum detection. There are those who whisper about primordial black holes, formed not from stars, but from quantum fluctuations in the earliest moments of the cosmos. Perhaps they float between galaxies, hidden by their very nature. Deep underground, detectors like Xenon and Lux sit in silence, buried beneath kilometers of rock to shield them from the noise of cosmic rays. They wait, for years sometimes, for a single dark matter particle to leave its signature a brief flash, a recoil, an echo. Nothing so far. But the search continues, because if we can't detect dark matter directly, we must redefine not just cosmology, but the very limits of what it means to measure, to observe, to know. But even dark matter, vast and mysterious as it is, may be only part of the story. At the core of many galaxies, including our own, lurk supermassive black holes, behemoths with masses millions to billions of times greater than the Sun. These are not theoretical curiosities. Their existence has been confirmed through observations of stars whipping around invisible points with impossible speed. In 2019, we saw one with our own eyes, the silhouette of the black hole in galaxy M87 captured by the Event Horizon Telescope. It was not a simple photograph, it was the image of absence. The shape of space-time torn open, framed by glowing plasma. These objects are where relativity and quantum theory come to war. Their event horizons are one-way boundaries, beyond which even light cannot escape. But inside, we don't know. A singularity and infinitely dense point lurks there, according to classical physics. But infinite is a word that physics uses only when it's run out of better explanations. What lies within might demand a theory of everything, something that unites gravity with the quantum world. We do not have that theory yet. Around many black holes swirl accretion disks, rings of gas and matter heating to millions of degrees as they spiral inward. These disks emit X-rays, radio waves, and sometimes, astonishingly, jets of particles that erupt perpendicular to the disk and shoot across intergalactic space at near light speed. Matter entering a black hole does not simply vanish, it becomes energy, structure, radiation. It is transformed. Yet even black holes are not eternal. According to Stephen Hawking, quantum effects at the event horizon cause black holes to radiate, slowly leaking energy over vast timescales, a process known as Hawking radiation. Over trillions upon trillions of years, they will evaporate, leaving only a whisper of mass behind. The ultimate fate of matter is not collapse, but dispersal. The universe remembers everything and then lets go. Still, not all mysteries are distant. Not all riddles lie in the dark voids between galaxies. Neutrinos, the universe's shyest particles, pass through us by the trillions each second. Born in nuclear reactions in the Sun, in supernovae, in cosmic ray collisions, they rarely interact with anything. They are nearly massless, ghost-like, and yet, in their elusiveness, they offer a portal into both the smallest and largest scales of nature. They oscillate, shifting between three flavors as they travel, a discovery that forced physicists to reconsider the standard model of particle physics. Their behavior suggests that the universe is not as symmetrical as we once thought. Deep underground detectors, giant vats of water or liquid argon, wait for rare flashes of Cherenkov radiation, the blue glow of a neutrino finally brushing against an atom. And then there are cosmic rays, charged particles from deep space that strike Earth with energies far beyond anything our accelerators can produce. Some come from solar storms, others from supernovae. The most energetic seem to come from active galactic nuclei or gamma-ray bursts. One particle, nicknamed the "Oh my God" particle, carried the energy of a baseball moving at 100 kilometers per hour packed into a single proton. What engine in the cosmos could hurl such a thing across time and space? We still don't know, but we are listening. Above us, between us, beneath our feet. The universe continues to speak not with sound, but with frequency, radiation, motion, and decay. It tells stories of birth and annihilation, of expansion and symmetry broken, and through it all runs a thread, the persistent curiosity of a species small enough to be humbled by the stars, and bold enough to chase them. Imagine for a moment that the sky itself is stretching, not metaphorically but literally, that every second, the very fabric of space between galaxies expands. The galaxies aren't flying through space like shrapnel from an explosion. Instead, the space between them is growing, like dough rising in a loaf of bread. Every galaxy is a raisin, and we on a small raisin called the Milky Way are drifting with the cosmic current. This expansion is not new. It has been happening since the beginning. Edwin Hubble first noticed it in the 1920s when he measured the redshift of light from distant galaxies. The farther away a galaxy was, the more its light was stretched toward the red end of the spectrum. This wasn't a Doppler shift from motion, it was the light being stretched as space itself expanded. This discovery shook the foundation of physics. The universe was not static, it was dynamic, unfolding, breathing. And then, in the late 1990s, we discovered something even more startling. Astronomers studying distant supernovae expected to find that the universe's expansion was slowing down, decelerating under the pull of gravity. Instead, they found the opposite. The expansion is speeding up. Galaxies are not just drifting away, they are accelerating apart. Something unseen, something pervasive, is driving this acceleration. We gave it a name, as we always do when we do not understand dark energy. This mysterious force makes up roughly 68% of the energy content of the universe. It is not matter. It is not light. It is not something we can touch or confine. And yet, it is everywhere woven into the vacuum itself. The emptier the space, the more dark energy it seems to contain. It is as though nothingness has power, as though the void pushes outward on the universe with relentless force. We have theories. Some suggest dark energy is a property of space itself, a cosmological constant first proposed by Einstein, then abandoned, then reconsidered. Others propose a dynamic field, quintessence, that changes over time. And in the deepest realms of speculative physics, some think dark energy is a sign that we are but one bubble in a foam of universes, each expanding, each governed by slightly different laws of physics. If the expansion continues indefinitely, a lonely future awaits. In 100 billion years, all galaxies outside our local group will recede beyond our cosmic horizon. They will vanish from our view not by moving faster than light in space, but because space itself will be expanding faster than light can travel through it. To observers in the far future, the night sky will be almost empty. The universe will seem small and quiet, even though it is vaster than ever. In more extreme models, the acceleration increases until it tears apart galaxies, stars, planets, eventually even atoms. This big rip is not just science fiction. It's a scenario supported by certain versions of dark energy. Other models suggest the acceleration will slow, or even reverse, leading to a big crunch where the universe collapses back into singularity, or perhaps a big bounce in an eternal cycle of expansions and contractions. These ideas are not just metaphysics. They are rooted in measurements of supernovae, of galaxy clusters, of the cosmic microwave background, but the data remains incomplete. The theory's speculative. We are building telescopes, satellites, and detectors not just to photograph the universe but to read its fate. And if space can expand, if it can bend under gravity and ripple under strain, then it can tear, it can fold, it can tunnel. Theoretical physicists imagine wormholes, bridges through space-time that connect distant points. If real, they could allow shortcuts between galaxies, or even between times. These are not inventions of science fiction, but solutions to Einstein's equations. The math permits them. Reality, so far, has not confirmed them. Wormholes require negative energy, exotic matter that repels instead of attracts. We do not know if such matter exists in stable form, but the idea lingers, tempting, like a trapdoor hidden under the fabric of space. If they exist, they could be the scaffolding of a deeper reality, a cosmic internet connecting distant realms not just across space but across versions of reality. Cosmic strings add another wrinkle. Hypothetical defects in space-time, thinner than atoms but stretching across galaxies. If they exist, they are scars from the early universe left behind during phase transitions as the cosmos cooled and symmetries broke. Like cracks in frozen water, they mark the places where reality changed too quickly to remain smooth. A cosmic string's gravity would be immense. A loop of string the size of a mountain could outweigh entire planets. If one passed between us and a star, it could split the image like a cosmic lens. If two strings collided, They might release a burst of gravitational waves strong enough to shake the Earth. So far, none have been found. But experiments are watching the sky for their signature: a sudden flicker, a peculiar lensing, a whisper in gravitational data. And what if the strings are not just leftovers? What if they are still active, vibrating, looping, shaping the evolution of galaxies, of space-time, of the rules we think are unchangeable? From these ideas emerges something even more audacious: the multiverse. If our universe began with inflation, a burst of exponential expansion, it might be just one bubble in a much larger foam. Other bubbles could form, each with different physical constants. One with no gravity, one with 6 dimensions of space, one where time loops back on itself. In some of these universes, stars may never form. In others, stars may burn eternally. A few might look eerily like our own. And in the grandest versions of the multiverse, every possibility permitted by quantum mechanics is realized somewhere. There is a version of you reading this paragraph in another language, on another planet, under a different sky. It is tempting to dismiss this as fantasy. And yet the same equations that describe our universe whisper of these possibilities. The mathematics does not stop at our event horizon. Even time, that most familiar illusion, may be stranger than we think. Near a black hole, time slows. Near a wormhole, it might loop. In quantum mechanics, the past and future are part of a single wave function, a smear of possibility that only collapses when observed. Some physicists suggest that time is not fundamental at all, that it emerges from entanglement and thermodynamic flow, like temperature from molecules. Entropy, the arrow of time, increases in one direction, but the laws of physics themselves are time-symmetric. In theory, a particle's behavior looks the same whether time moves forward or backward. So why do we remember the past and not the future? Why does cause precede effect? Perhaps the universe began in a state of extremely low entropy, a condition so improbable it demands explanation. Inflation might provide one. Or perhaps, as some suggest, the universe is time-symmetric in total, with 2 halves, one expanding forward, the other backward from a shared origin. We are simply embedded in one side of the temporal mirror. None of this diminishes the mystery. If anything, it deepens it. We thought we lived in a universe of stars and void. Instead, we find ourselves adrift in a sea of invisible matter, propelled by a force we cannot name, obeying laws we cannot yet unify. And still we observe, we calculate. We build machines to listen for whispers in the dark. A century ago, the idea of other galaxies was radical. 50 years ago, the Big Bang was still debated. 20 years ago, we had never seen a black hole. Science moves slowly, but it moves. Perhaps one day we will confirm the existence of cosmic strings, of wormholes, of dark energy's true nature. Perhaps we will discover that the universe is not a thing, but a process, a self-organizing system without center or edge, governed by laws that emerge from deeper principles we have yet to glimpse. Until then, we look outward and inward. We study the distant quasars and the quantum foam. We listen to gravitational waves and neutrino showers. We stare into the abyss and find ourselves reflected back in it. For in every photon that traveled 1 billion years to reach our eyes, in every vibration of a subatomic particle, in every improbable law that binds entropy and emergence, lies the same message: the universe is alive with possibility. Somewhere, orbiting a distant sun you'll never see with the naked eye, a world turns. Its sky may glow orange. Its oceans might stretch thousands of kilometers deep. Its continents could be frozen, or covered in methane rains, or cloaked in a jungle of alien biochemistry. This world has never seen Earth, and yet it exists, not just in theory but in data, in light, in numbers. A few decades ago, the idea of planets beyond our solar system, exoplanets, was pure speculation. Today, we've cataloged over 5,000 of them. Some orbit stars smaller than our sun, glowing red in the dark. Some whirl around their suns in just hours. Others drift so far from their stars that they are colder than Pluto. We've found super-Earths, mini-Neptunes, lava worlds, and rogue planets wandering alone through the galaxy. How do we see something so small, so far? Mostly, we don't. We infer them. When a planet passes in front of its star, it causes a tiny dip in brightness. That's the transit method. When a star wobbles, pulled gently by an orbiting planet's gravity, its light shifts in color. That's the radial velocity method. These two techniques, refined over years, allow us to detect planets we'll never directly image. The diversity is staggering. Some exoplanets orbit so close to their stars that their surfaces boil, with temperatures hot enough to vaporize rock. On these planets, it might rain molten iron. Others are water worlds, entire planets with deep oceans and no land. A few, like 55 Cancri e, are believed to be composed largely of carbon and may have layers of diamond beneath their crusts. But among this zoo of worlds, one class fascinates us most: Earth-like planets in the habitable zone. Not too close, not too far from their stars. Just right for liquid water to exist on the surface, a necessary condition for life as we know it. One of the most intriguing is Proxima b, orbiting the red dwarf Proxima Centauri, just 4.2 light-years away. It's likely tidally locked, one side always facing its star, the other shrouded in perpetual night. Could life survive in the twilight band between day and night, where conditions might be more temperate? Even more promising is the TRAPPIST-1 system, a compact family of 7 Earth-sized planets orbiting an ultra-cool dwarf star. 3 of them lie in the habitable zone. The entire system could fit within the orbit of Mercury, and from the surface of one TRAPPIST planet. The other 6 might hang in the sky. Larger than the Moon appears from Earth, a cosmic archipelago, each island a potential home. With the launch of the James Webb Space Telescope, we've taken a major step forward. JWST can analyze the atmospheres of exoplanets by studying the starlight that passes through them during a transit. If we detect certain gases like oxygen, methane, or ozone in the right combinations, they could be biosignatures, hints of life. And yet, so far, we've heard no voice but our own. The silence is profound. Despite billions of potentially habitable worlds, no signal has come. No beacons, no engineered pulses, just the static of nature. This is the heart of the Fermi paradox. If the galaxy teems with worlds, where is everyone? Perhaps we are early. Perhaps we are alone. Perhaps intelligent life is rare, or short-lived, or chooses to remain silent. Perhaps civilizations rise and fall like waves, never overlapping in time. Or perhaps we're not listening correctly. We have scanned radio frequencies for decades, but what if alien civilizations use communication methods beyond our understanding? Quantum entanglement, neutrino beams, gravitational wave modulation technologies we haven't developed yet. We could be surrounded by conversations we simply don't know how to detect. Or maybe life is common, but intelligence is not. Microbial life might flourish in subsurface oceans, under the ice of moons like Europa or Enceladus. These icy worlds, within our own solar system, are among the best candidates for finding life. Beneath kilometers of ice, warmed by tidal flexing from their giant planet hosts, lie oceans possibly teeming with simple organisms. The Cassini spacecraft flew through the geysers of Enceladus and detected organic molecules, carbon-based compounds that are the precursors to life. Future missions will aim to land, drill, taste, because the question is no longer is there another Earth, but how many? And beyond that, what kind of life calls them home? Are they single-celled organisms, photosynthesizing in alien oceans? Are they intelligent creatures with languages, cultures, philosophies? Have they built cities that glow in the night? Or are they like us, just beginning to lift their eyes to the stars? The search is not just technological, it is emotional, philosophical. It challenges our place in the cosmos. If we are alone, then life is rare and precious beyond measure. If we are not, then we are part of something vast and ancient. Either way, the night sky is no longer a mystery of dots. It is a map of possibilities. For centuries, we wondered whether our own planetary system was unique, a solitary jewel amid darkness. Now, we know better. Thousands of exoplanets have been discovered, each orbiting its own distant sun, each a candidate in the grand lottery of life. These planets challenge our imagination. Some are scorched gas giants orbiting within whispering distance of their stars. Others are frozen, lonely worlds bathed in dim twilight. But among them lie rocky planets in temperate zones, places where liquid water could flow, where chemistry could evolve, where life might stir. Imagine watching a star blink ever so slightly every few days. That blink, a dip in brightness, is a planet passing in front. This is the transit method, our most successful technique for detecting exoplanets. Other worlds reveal themselves by tugging gently on their stars, inducing a wobble detected through Doppler shifts in the starlight. These tiny clues, almost imperceptible, have unveiled a cosmic menagerie. We find hot Jupiters, so close to their stars that iron may fall as rain. We find ocean worlds, planets entirely covered in liquid, where no land interrupts the tides. Diamond planets, carbon-rich and compressed into crystalline continents. Super-Earths, larger and denser than our world, may possess thick atmospheres or violent tectonics. What do these worlds mean for life? The answer rests in zones not of politics or economics, but of temperature. The habitable zone around a star is where water can remain liquid, given the right atmospheric pressure. Too close, and oceans boil away. Too far, and they freeze into silence. Within these delicate bands, possibility unfolds. Proxima b, just over 4 light-years away, is a candidate. It orbits a red dwarf, a star smaller and cooler than our Sun. One side of the planet may face eternal day, the other, unending night. Could life adapt to such a contrast on TRAPPIST-1's 7 rocky planets? Several reside in their star's habitable zone. Imagine standing on one and seeing 6 other worlds hanging in the sky, an archipelago of potential biospheres. The James Webb Space Telescope is now our eye into exoplanet atmospheres. It searches for biosignatures, gases like oxygen, methane, and carbon dioxide in ratios that hint at biology. Life, if it exists, may not be carbon-based. It may not breathe or metabolize as we do, but it might still alter its world in detectable ways. And what if life is not microbial, but technological SETI? The search for extraterrestrial intelligence listens for patterns that cannot arise from stars or magnetospheres. A structured signal, a repeating pulse, a narrowband radio beam from a distant system, any of these could change our place in the universe forever. But silence persists. Still, this silence isn't absence. It may be latency, or it may be concealment. Advanced civilizations might hide themselves, broadcasting only through methods we cannot yet detect, modulating neutrinos, gravitational waves, or quantum entanglement. The cosmic haystack is vast. We are only now learning to sift its fields. Perhaps intelligence is rare, not because it fails to arise, but because it tends to self-destruct. Nuclear war, climate collapse, runaway AI civilizations may bloom like brief flowers and then vanish. Or perhaps we're early. Perhaps life is just beginning to stir across the cosmos. Now tilt your gaze from potential to history. How did we even get here? The story of cosmic expansion began with Edwin Hubble. He discovered that galaxies are not static, they are fleeing. The farther they are, the faster they recede. It is not that they move through space. Space itself stretches. Like raisins in rising dough, galaxies drift apart as the cosmic loaf expands. This discovery shattered the idea of a steady-state universe. It implied a beginning, a moment when all was compact, hot, and dense. A singular origin, the Big Bang. But expansion had another surprise in store. In the 1990s, observations of distant supernovae revealed that the universe isn't just expanding, it's accelerating. Galaxies are pulling away faster and faster. Some force repulsive, invisible, omnipresent is driving them. We call it dark energy. Dark energy is not a substance we can bottle. It does not clump or swirl. It is more like a pressure built into the fabric of space-time itself. It makes up nearly 70% of the universe's energy content. Yet we do not know what it is. The fate of everything may hinge on it. If dark energy remains constant, galaxies will drift so far apart that each will become a cosmic island, alone in the void. If dark energy grows stronger, it could one day rip apart galaxies, stars, planets, even atoms. This big rip is hypothetical, but terrifying. Or maybe dark energy will fade. Maybe the expansion will slow, halt, reverse. A big crunch, or a big bounce, where a collapsed universe rebounds into another cycle. We measure, we model, we map. But at the heart of the cosmos is a question we cannot yet answer. What is the engine behind the acceleration? We look into the void, and it stares back with silence and speed. Yet not all of space is silent. Some theories whisper of scars, cosmic strings. These are defects in the very fabric of space-time, formed in the early moments after the Big Bang. Thinner than an atom but longer than a galaxy. These strings could warp light, shake space-time, emit gravitational waves. They are not strings like in a violin, but strings in the sense of dimensional tiers. If they exist, they could be tools, gateways, even to wormholes, shortcuts across space and time, theoretical, speculative, but rooted in the same equations that gave us black holes, neutron stars, and gravitational waves. Cosmic strings could vibrate with energy and vanish in loops. Or they might still stretch across the sky, invisible to our eyes but not to our instruments. We search for their fingerprints in the cosmic microwave background in the way light bends around invisible corners. The dance of existence continues in silence beyond the cosmic horizon. All that has come before black holes, dark matter, exoplanets finds a home in a universe that is still expanding, still evolving. But beyond the phenomena we observe, the deepest questions begin. What gave rise to this universe? And why these laws, these constants, this balance that allows complexity, life, and awareness? In the first trillionths of a second after the Big Bang, something extraordinary happened. Not the explosion itself that's a metaphor, but the rapid swelling of space itself. Inflation. A period when the universe ballooned faster than light, driven by a mysterious energy embedded in the quantum vacuum. During this brief era, quantum fluctuations, microscopic wrinkles in the energy field, were stretched to cosmic scales. They became the seeds of all future galaxies, all future us. These primordial ripples are imprinted in the oldest light we can detect, the cosmic microwave background. It shows us tiny variations in temperature, barely 1 part in 100,000. But those tiny differences determine the shape of the universe to come. Regions slightly denser than average drew more matter, forming stars, clusters, and vast cosmic filaments. The great web of the universe began as a trembling in a quantum field, and this is where theory brushes against the edge of the unknowable. Inflation may not have been a one-time event. Some physicists propose eternal inflation, a bubbling cosmos where each bubble is a universe. Our universe, then, is one among an infinite multiverse. Each bubble may have different physical laws, different particles, even different dimensions. Perhaps, in one, stars never formed. In another, time runs backward. In another, life is silicon, not carbon. These ideas are not just speculative dreams. They emerge from the math that governs the quantum and cosmological realms. String theory, for instance, suggests a universe with 10 or more dimensions, most curled up tightly, beyond our detection. It offers a framework where gravity and quantum mechanics can finally merge. But even if these theories are right, how could we ever test them? What would it mean to peer beyond our cosmic bubble? Could gravitational waves from other universes leave a scar in our sky? Could high-energy particles from a neighboring cosmos punch through the veil? Scientists seek signatures in the sky, unusual cold spots, unexpected alignments, anomalies in the cosmic background that might hint at collisions with other universes. And still, the question deepens. Why is there something rather than nothing? Why these laws, this geometry, this dance of energy and entropy? The anthropic principle suggests we live in a universe compatible with our existence. Others might be barren, short-lived, or chaotic. But this is not a satisfying answer. It begs for more. It hungers for insight. Philosophers and physicists converge here. Some suggest the universe is a mathematical structure, existing because mathematics is inevitable. Others imagine a self-creating cosmos, one that brings itself into being through a loop of quantum cause and effect. Still others invoke the simulation hypothesis that all of this, from quarks to quasars, is information processed in some vast computational substrate. No matter the answer, the search itself is sacred. And so we push forward. We build better telescopes. We refine our theories. We teach our machines to sift patterns from noise. We test the edge of what is knowable. Yet, in the midst of this cosmic ambition, we return to something deeply human. The awe of seeing a sunrise, the touch of a child's hand, the memory of a loved one. These, too, are part of the universe, no less fundamental, no less cosmic. The neutrinos passing through your body right now were forged in stellar cores and supernovae. The calcium in your bones, the iron in your blood, the oxygen you breathe, all made in ancient stars. You are not just in the universe, you are of it. A way for matter to become self-aware, to dream. And dream we must. Of life beyond Earth, of civilizations rising among exoplanets, of technologies that fold space, of messages carried not by light, but by gravitational whispers. The Voyager probes, launched in the 1970s, now drift through interstellar space, carrying golden records etched with music and greetings from Earth. They are tiny ambassadors, drifting farther from us each year, but also closer to eternity. We will go further, with light sails, fusion drives, and maybe someday wormholes. We will seed new worlds, if not with our bodies, then with our minds, our machines, our stories. Perhaps the universe's greatest mystery is not why it exists, but why it allows for beings who can ask why. Beings who can fall in love, grieve, create symphonies, and build particle accelerators. So we end not with an answer, but with an invitation to wonder, to question, to keep listening to the quiet song of the cosmos, knowing that in some subtle way, it is listening back.
There are moments when the night appears too vast to understand, and yet too intimate to ignore. The eye, born from stardust, finds itself compelled to return that gaze. But the stars offer no answers. They shine not to guide us, but because they must. Still, we ask. Still, we build mirrors of glass and algorithms to decode what lies between them. The James Webb Space Telescope did not arrive as a symbol, it arrived as a silence, slowly unfolding in the cold vacuum, petal by petal, mirror by mirror, launched not to replace, but to extend what our sight could become. Not merely a machine, but a question sharpened to a point of light. And light is all it needs. The kind that began its journey when Earth had no cities, no names. The kind bent by galaxies, stretched by cosmic expansion, softened by time. It is not the present the telescope sees, but a museum of ancient fire. The telescope, orbiting far beyond the moon, bathes in shadow. It carries no flashlight. Its mirrors are polished to reflect the oldest light, the kind no eye has seen. Not the sharp blue of a nearby star, but the long red whisper of something impossibly far. It looks not into space, but into time itself. As its gold-plated segments aligned, they captured not a single image, but a depth. Each dot in its field, a galaxy. Not a star, a galaxy. Hundreds of billions of stars in every speck. Structures bent into arcs by gravity so strong, they twist light like silk. What we see is not what is. What we see is what was, revealed by the time it takes to arrive. Among those arcs and fragments are galaxies so old, they defy expectation, formed when the universe was young and raw, less than 500 million years past its birth. They are compact, rich in stars, strangely mature. Their presence unsettles timelines. If these galaxies existed so soon after the beginning, then our models must stretch to accommodate them. They are not errors, they are revelations. Yet revelations bring discomfort. The data does not confirm, it provokes. Galaxies shine when they should not yet exist. Their chemistry is too advanced, their structures too settled. We are not disillusioned. We are invited to rethink. Perhaps the formation of galaxies was more urgent than imagined. Perhaps the early universe was not uniform, but wild with possibility. Perhaps our assumptions of symmetry and gradual structure must yield to new models, ones where turbulence, gravity, and dark matter assembled stars faster, brighter, denser than expected. This is not a crisis. It is the work to revise, not resist, to see the image not as disruption, but as instruction. The telescope shows us a universe not that betrayed us, but that moved faster than we anticipated. Its silence is not a refusal, it is a gift of deeper questions. And we, tethered to a small planet under an aging star, now witness the light of things born when the cosmos itself was a child. To see them is not just to see history, it is to meet the boundaries of our understanding, and to walk into them willingly. A mirror turned outward also turns inward. As the James Webb Space Telescope reached deeper into the sky, it inadvertently drew us into a closer encounter with ourselves. For all its precision and distance, the most arresting images it returned were not of alien terrain or spectacular collisions, but of light curved, reddened, ancient, light that had crossed epochs to find a home on a golden mirror. Among these signals were arcs of light wrapped around invisible centers. Einstein had predicted it long ago that gravity could lens light, bend it not metaphorically but geometrically. Here it was, visible and undeniable cosmic lenses magnifying the unreachable. Behind them, galaxies swam into view that would otherwise remain hidden. They shimmered like ghosts, brought into existence by the gravity of clusters layered between us. Through these lenses, the telescope captured galaxies whose ages defied our calendars. Their redshifts, markers of distance and time, suggested they had formed mere hundreds of millions of years after the Big Bang. And yet, they bore the signatures of maturity, heavy elements forged in stars, structures suggesting rotation and gravity-bound systems, not chaos but complexity. This prompted a quiet discomfort among cosmologists, not because it challenged the data, but because it whispered that the universe may have grown up faster than our equations had allowed. If galaxies of such mass and richness existed so early, then the seeds of structure must have taken root in even deeper darkness. Perhaps inflation planted them more effectively than we thought, or perhaps something in our modeling of early star formation, of the interaction between gas and gravity, needed reimagining. And so, the telescope became not just an eye, but a teacher. It asked, without words, whether our explanations were too tidy, too linear. It showed us that the cosmos is not obligated to match our expectations. The models exist to interpret the sky, not dictate it. Yet even as the early universe offered its riddles, the nearer cosmos answered with texture. Nebulae bloomed in infrared, revealing layers of gas and dust invisible to previous instruments. Structures once blurred became sharp. Birthplaces of stars glowed with the residue of ignition. We saw not just forms, but processes. These stellar nurseries, once only hints, now unfolded in cascading detail. The pillars of creation no longer hid behind shrouds, they glowed, pierced by the very light they had birthed. Regions of turbulence, where gravity struggled against radiation, painted pictures of the tension from which suns are born. But perhaps most profound were the spectra. Stripped of beauty, they offered the raw fingerprints of atoms. In them, scientists found traces of water vapor, carbon dioxide, and methane not just in nebulae, but in the atmospheres of exoplanets orbiting distant stars. These were not just points of light, they were places, with weather, with chemistry, with potential. A planet hundreds of light years away, invisible to any eye, suddenly revealed what clung to its skies. The composition of distant worlds, once a fantasy, had become data. And with that, the line between astronomy and biology thinned. The search for life no longer lived only in hopeful signals or surface images. It now had molecular paths to follow. The telescope, in its quiet task, made the improbable intimate. It reminded us that light, no matter how old, still speaks. That distance does not erase detail, and that from our small perch, we are now listening more carefully than ever before. In the realm of the very distant, the very small often holds the most sway. Between galaxies and nebulae lies a scaffolding that light alone cannot reveal, a hidden web shaped by gravity, populated by the invisible, and animated by laws yet unfinished. The telescope does not see this web directly. It traces it through absence, through distortion, through the motions of what should not move the way it does. Every image that reaches its mirror is touched by dark matter. This unseen substance, outweighing the ordinary by 5 to 1, clings to galaxies like a skeleton beneath the flesh of starlight. Without it, those galaxies would not hold together. Their stars would fly apart under their own speed. With it, structure endures. The telescope's images, then, are not merely of light, they are portraits shaped by shadow. The gravitational lensing of distant galaxies maps the pressure points of dark matter. Where light bends, mass resides. The more dramatic the arc, the heavier the weight behind it. And so, by observing distortion, we glimpse the silent architecture of the cosmos. But gravity is not the only force at play. The telescope peers into wavelengths designed to escape interference. It sees through veils of dust that once cloaked entire regions from view. That dust, forged in the death of stars, is both an obstruction and a womb. It hides and reveals in equal measure. What Webb sees are not just clearer pictures, but different truths. In the early universe, it finds galaxies forming with extraordinary compactness. Starburst galaxies rushing through their supply of gas at 10, 20, 50 times the rate of the Milky Way emerge in abundance. These cosmic forges, seen at redshifts higher than 10, should not yet exist by some models. And yet they glow defiantly, their ultraviolet light stretched into infrared by the expansion of space. Within these galaxies, the telescope begins to uncover chemical signatures once assumed too complex for such an early time. Elements heavier than helium, born in the hearts of massive stars, appear in quantities that imply a rapid recycling of stellar generations. Death and rebirth on cosmological timescales far faster than we expected. The presence of such metals this early means stars were forming, dying, and enriching their environments at a breathtaking pace. It reshapes our understanding of galactic metabolism. It forces us to ask whether the timeline of the first supernovae, the emergence of black holes, and the ionization of the intergalactic medium needs to be rewritten. Ionization, the process by which neutral hydrogen was torn apart into protons and electrons, is one of the great transitions in cosmic history. The telescope now sees its traces more clearly. It captures the glow of galaxies as they punch holes in the neutral fog, letting light travel freely for the first time since the cosmic microwave background was born. This age, the epoch of ionization, is no longer an abstraction. It is being mapped, layer by layer, galaxy by galaxy. And in doing so, we edge closer to answering the most elusive question: how did the cosmos turn from darkness to complexity? Not with a single light, but with a storm of them. Not with gradualism, but with convulsion. The early universe, once thought to be sleepy, appears instead like a forge, loud, crowded, raw. Its tempo has changed, its rhythm quicker, its story less linear and more emergent. And through it all, the telescope remains a listener, not to sound, but to structure, not to noise, but to nuance. Each photon it catches is a vote for reality over theory, a reminder that the universe is under no obligation to mirror our expectations. Beyond the veil of time and radiation, there are worlds, not imagined, but measured, not mythic, but spectral. The James Webb Space Telescope does not photograph oceans or mountains. It catches atmospheres. It reads starlight that has passed through the breath of alien planets, and in that thin filtering detects what lingers in the air. Water vapor, methane, carbon dioxide, molecules once measured only on Earth, now shimmer in the light of stars hundreds of trillions of kilometers away. They drift across gas giants far closer to their suns than Jupiter dares orbit. They settle into skies of planets larger than Earth, but smaller than Neptune. They mark conditions, not proof, but potential. These are exoplanets, once speculative, now catalogued by the thousands. Their orbits dim stars by a fraction, and from those dimmings we measure size, period, distance. Webb adds the missing piece: chemistry, by watching a planet transit its host star and capturing the starlight that skims its atmosphere. The telescope unveils the fingerprints of gases, even at whisper-level concentrations. In one such world, a gas giant orbiting tightly to a dim red sun, Webb detects carbon-bearing molecules with clarity no previous mission could achieve. The spectrum flattens, then curves, revealing a chemical complexity that stirs curiosity. This is not life, but it is not lifelessness either. It is the context from which life might emerge. It turns its eye to TRAPPIST-1, a system of 7 rocky planets, some of them poised in the star's habitable zone. It watches as these Earth-sized worlds eclipse their cool sun. Their signals are faint, fragile, but Webb persists. It catches hints of carbon dioxide in one, perhaps water in another. The atmospheres are thin, the noise high, but the story begins. These are not photographs to frame, they are codes to parse. What Webb gives us is not certainty, but direction. It points to the chemical conditions under which biology might arise. It does not promise discovery. It opens the door through which discovery might walk. But the telescope also reminds us that habitability is not a binary. It is a spectrum. It depends on the dance between starlight and atmosphere, between magnetic fields and geological cycles, between temperature and time. Earth is not the only solution. It is a single fortunate variation among many possibilities. We now understand that life, if it exists elsewhere, may not mirror us. It may not walk or think or build. It may flicker as microbial shadows under ice. It may breathe ammonia, not oxygen. It may never dream, but it may endure. This is the beauty of Webb's revelations. It does not anthropomorphize the cosmos. It humbles us. It removes the presumption of centrality and replaces it with participation. We are not the measure of the universe's creativity. We are one of its outcomes. And so, in each spectrum captured, we see less of ourselves and more of the possible. Each distant world is not an echo of Earth, but a variation in the melody of matter. Some may be barren, some may bloom. We do not know. But the knowledge that we can even ask, that we can even begin to test, marks a shift in our place. For the first time in history, life on Earth is no longer merely wondering. It is listening. It is measuring. It is looking not outward for confirmation, but outward for connection. The farther we look, the stranger the questions become. In the deep field images of the James Webb Space Telescope, the universe stretches into a canvas of paradox, brilliant with clarity, yet haunted by limits. Not the limits of technology, but the deeper ones, etched into the fabric of existence itself. For all we can see, there are boundaries we cannot cross, and behind them may lie the reason we can see at all. Cosmology has always walked the knife's edge between physics and philosophy. Now, with eyes sharper than ever, it begins to ask whether reality is what it appears to be or whether it has always been a construction, not a fabrication, but a structure so elaborate it deceives even the senses that probe it. Some voices whisper of a simulated universe, not as metaphor but as model. If the cosmos behaves like a computation, if its constants are finely tuned and its information conserved with perfect fidelity, then perhaps we are embedded in something designed by nature, by intelligence, or by something we cannot name. This is not a claim, it is a question. And Webb, though silent on such speculation, adds weight to its possibility. Because in seeing deeper, we find more precision, not more randomness. The early galaxies, once assumed to be chaotic and primitive, reveal order and complexity, the patterns of star formation, of element distribution, of gravitational assembly. They all cohere too well. It is as though the universe was ready for complexity from the beginning. The cosmic microwave background, the afterglow of the Big Bang, is uniform to 1 part in 100,000. The equations that predict its distribution work. They work too well. Inflation theory, dark matter, dark energy, they form a model that explains nearly everything. And yet, none of these components are directly understood. If the universe is a simulation, then perhaps the speed of light is not just a limit, but a boundary condition. Perhaps quantum uncertainty is not a bug, but a feature. Perhaps black holes are firewalls, points where information is compressed, not lost. These are not answers, but provocations, born not of science fiction, but of mathematics and physics pushed to the edge. Webb cannot confirm or deny any of this, but it fuels the question with every unexpected detail. It confronts us with the raw fact that the universe has rules, and that we are capable of uncovering them. That very capability demands reflection. What kind of reality allows its creations to comprehend its scaffolding? If this is not design, then it is poetry of the highest kind, a universe that, without intent, gives rise to meaning. If it is design, then the implications exceed any theology, not because we are special, but because we are not. We may be simulations within simulations, observers within observers, shadows cast by deeper machinery. Yet meaning persists, regardless of foundation. Whether real or rendered, our questions are real. Our wonder is real. The telescope, unfeeling and precise, becomes a vessel for that wonder. It gathers data, but we assign the weight. We feel the astonishment. We press the questions further. The night sky is no longer just a map of stars. It is a language, a system, a challenge. And in decoding it, we learn not just what the universe contains, but what it permits us to become. In the end, what Webb reveals is not only what is there, but what is possible. A universe pregnant with structure, with symmetry, with surprise. A reality where time unfolds not as a straight path, but as a spiral returning again and again to the same questions, each time with sharper tools, deeper thought, and greater humility.
If a photon of light from 13 billion years ago is still traveling through a forgotten corner of the universe, what does it want to tell us? Its journey began in a cosmos that was still a furnace, a place of first things, before the Earth had formed, before our sun had even ignited from its dusty cradle. That single particle of light carries a memory, a snapshot of a time we can only imagine. The James Webb Space Telescope is a machine built not just of mirrors and sensors, but of a deep human need to intercept that message, to catch that ancient light and decipher its story. And with the first images it has captured, it has begun to shed light not only on the birth of stars, but on the history of our own understanding. What we are seeing through this new eye is anything but ordinary. From galactic collisions that sculpt the heavens to distant planets bearing the chemical fingerprints of life. From explosions of energy that defy the known laws of physics to mind-boggling details about the very first moments of the universe. Everything is contained within these images. This is not just an act of observation. It is an invitation to join humanity in a great and unsettling discovery. A moment when our gaze has truly turned toward infinity. From the moment it began its mission, the James Webb Space Telescope turned the eyes of the entire world toward the deepest, darkest corners of space. However, The first images of the earliest galaxies were not what scientists had expected. The images showed galaxies with a much more advanced and organized structure than anyone had previously thought possible in the early stages of the universe. This single finding revealed, with startling clarity, that all our established theories regarding the formation of the universe and the evolution of galaxies needed to be re-examined. While it was previously expected that galaxies at the beginning of the universe would be complex and chaotic knots of gas and young stars, the impossibly clear images from the Webb telescope showed the exact opposite. Some of these ancient galaxies exhibited an unexpected level of order and complexity, with distinct spiral arms and dense central bulges, structures that should have taken billions of years to form. This highlighted significant, gaping holes in our understanding of the conditions at the beginning of the universe and immediately accelerated research efforts worldwide. This profound surprise rippling through the scientific community has led astronomers to re-examine existing theories with a new sense of urgency. The formation of the first galaxies and the mechanisms of star birth are now being questioned at a fundamental level. NASA's own statements have emphasized the monumental importance of this discovery and the pressing need for further research. Therefore, the first images obtained may only be the beginning and are now seen as a harbinger of much more surprising discoveries awaiting us in the depths of the universe. A universe that is proving to be far stranger and more creative than we had ever dared to imagine. The data streaming back from the James Webb Telescope has revealed results that threaten to overturn our most long-held assumptions about the age of the universe itself. For decades, the scientific community had accepted the age of the universe to be approximately 13.8 billion years, a number derived from precise measurements of the cosmic expansion rate. But the new observations from Webb suggest that the universe may be much older. These unexpected results indicate that our most fundamental cosmological models may need to be re-evaluated from the ground up. The data collected by Webb showed that galaxies that appeared in the earliest stages of the universe may be far older than the standard model allows. In fact, the calculated age of some of the stars within these galaxies is almost older than the currently calculated age of the universe itself. This paradoxical, impossible situation suggests that the calculations regarding the expansion rate of the universe and its beginning, which scientists have been using for a long time, may be fundamentally incorrect. NASA has intensified its detailed observations to confirm this startling situation. Currently, scientists around the world agree that the cosmic microwave background radiation, the echo of the Big Bang, and the measured rate of cosmic expansion need to be reanalyzed in light of this new, contradictory data. If the universe is indeed older than we previously thought, then the Big Bang theory and all models of the universe's expansion rate may require a profound and difficult revision. The depth and significance of this discovery will help us to better understand the true initial conditions of the universe. At the same time, clarifying the true age of the universe is also of great importance in predicting its ultimate fate. If this calculation error is confirmed, even the answers to the most fundamental questions in cosmology may need to be rewritten, and the story of our universe will have a new and much longer first chapter. One of the most shocking discoveries made using the James Webb Telescope was the identification of a galaxy that appears to be significantly older than our own Milky Way. This discovery, which completely overturns the traditional assumptions about the formation of the universe, calls into question everything we thought we knew about the universe's long and complex development process. While scientists had long believed that the Milky Way was one of the oldest and most established galaxies in the universe, this new finding has revealed that this is not the case at all. This ancient galaxy is not only older than expected, but it also possesses a highly developed and organized structure. This indicates that even in the very early stages of the universe, there were already quite complex and mature galaxies, fully formed and settled. Such a finding raises the pressing question of how the vast, diffuse clouds of gas and dust in the early universe could have so rapidly formed stars, planets, and the intricate structures of a modern galaxy. This single galaxy discovery could rewrite the entire chronology of cosmological history. Scientists are now re-evaluating the processes of galaxy formation in the earliest stages of the universe. It is now clear that new theories need to be developed to explain the shockingly early emergence of such old and complex galaxies. The data sent back by James Webb offers entirely new perspectives on the physical conditions that must have existed in the early stages of the universe. NASA researchers are continuing their detailed analysis of this particular galaxy, and examining its structure and characteristics will help us to better understand the violent, rapid, and creative processes that dominated the early cosmos. These findings are likely to continue to make a big splash in the scientific world for many years to come, as we slowly piece together a new and more accurate history of our universe. One of the most striking discoveries made by the James Webb Telescope was the identification of a massive cosmic wall in a dark and previously unmapped region of space. This colossal structure has astonished scientists because it is so large that it could affect the large-scale distribution of matter throughout the entire universe and is a previously unseen type of cosmic formation. Scientists say that this giant cosmic wall fundamentally challenges our understanding of the structure of the universe. There is currently no definitive information about how this massive structure formed, or how it has evolved alongside the relentless expansion of the universe. The discovery of this cosmic wall even calls into question some of the fundamental assumptions of our most basic cosmological principles, such as the idea that the universe is roughly the same in all directions on the largest scales. NASA researchers have launched an intensive and ongoing study to better understand the contents and formation of this mysterious wall. Initial analyses indicate that this cosmic wall is a massive, filamentary structure composed of thousands of galaxies and vast, invisible clouds of dark matter. The details of this discovery could add a whole new dimension to our theories of dark matter and how it shapes the cosmos. If the existence and structure of this giant cosmic wall are confirmed, the theories that explain the large-scale structure of the universe could undergo radical and profound changes. Thus, the James Webb Telescope will have opened a completely new chapter in our long and ongoing quest to understand the universe. Among the torrent of data collected by the James Webb Space Telescope from the deepest reaches of space, an extremely surprising and deeply puzzling situation has emerged. A series of mysterious light signals, recorded by the telescope with incredible precision, have left astronomers in a state of profound shock. The frequency, power, and highly repetitive pattern of these signals do not match any known astronomical phenomenon to date. Scientists are currently unable to determine the source of this mysterious light, and all of our existing theories are now being called into question. These regular, repeating signals coming from the depths of space have reignited the long-simmering discussions about whether we are truly alone in the universe. The highly periodic and structured nature of the signals is seen by some astronomers as potential, though highly speculative, evidence of intelligent life. However, such extraordinary claims are still scientifically weak and require much more data to be taken seriously. NASA has not yet ruled out the possibility that these signals are of a completely natural, though previously unknown, origin. These mysterious lights have begun to be tracked by many different telescopes and astronomy centers around the world. Investigations conducted through a massive international collaboration have confirmed the unusual and artificial-seeming characteristics of these signals. Scientists are now working to develop a wide range of hypotheses about the source of these light signals. Pulsars, neutron stars, or a completely unknown type of astronomical event could be the source of these lights. However, if these signals do turn out to be signs of extraterrestrial intelligence, it would undoubtedly be the greatest discovery in the entire history of science. This possibility could revolutionize space exploration and our place within the cosmos. For this reason, NASA is currently mobilizing all of its available resources to find the source of these enigmatic signals. One of the most exciting discoveries made by the James Webb Telescope was the identification of a potentially habitable planet in a region surprisingly close to Earth. The size of this planet, its atmospheric composition, and its precise distance from its star provide the ideal conditions for life to exist. This single discovery has strengthened the possibility of finding extraterrestrial life more than ever before. Scientists have indicated that the likelihood of finding liquid water on the surface of this new planet is quite high. Initial analyses of the planet's atmosphere suggest that it contains essential components for life, such as carbon, oxygen, and water vapor. This provides strong and compelling evidence that the planet's surface may harbor conditions suitable for the emergence and sustenance of life. NASA plans to conduct more extensive observations in the coming months to study this planet in much greater detail. The James Webb Telescope is now collecting detailed data that will clarify the precise chemical composition of the planet's atmosphere and its average surface temperature. If it is confirmed that this planet is indeed habitable, it could mark the beginning of a completely new era in human history. Such discoveries have the potential to fundamentally shake humanity's long-held perception of its isolation in the universe. NASA is already preparing new space missions to detail the physical conditions of this discovered planet. The possibility of turning humanity's ancient dreams of one day settling on a different world into a tangible reality is now higher than ever. Thanks to this remarkable discovery, among the data sent back by the James Webb Telescope are images of some completely unexpected and violent cosmic events. Massive explosions and intense energy emissions in the far corners of space have prompted scientists to take immediate action. The sheer scale and intensity of these events are far beyond anything previously encountered in known astronomical events. NASA is currently investigating these events very seriously. One event in particular has been identified as a massive explosion on a galactic scale. The source of this explosion is currently unknown, and its energy level is incredibly, almost impossibly high. The devastating effects of this explosion on the surrounding star systems and planets are currently being investigated with great urgency. NASA is deeply concerned that such events could also occur much closer to Earth, posing a potential threat to our own solar system. To better understand these cosmic events, NASA has put astronomical observation centers around the world on high alert. The international astronomy community is now intensively analyzing the events observed by the powerful telescope. The cause of these massive energy explosions could be the collision of supermassive black holes or entirely new astronomical phenomena that are still completely unknown to us. Such unexpected events once again reveal how violent, chaotic, and unpredictable the universe truly is. NASA is continuing its in-depth analysis to determine whether such events pose a direct and imminent threat to Earth. Unraveling the mystery of these events in the coming period will play a critical role in understanding the dynamic and ever-changing structure of the universe. The James Webb Telescope has caused a profound stir in the scientific community by capturing the first clear and unambiguous images of complex organic molecules in the deepest reaches of space. This monumental discovery has revealed just how widespread the fundamental building blocks of life are throughout the universe. The clear observation of these molecules, which were previously only speculated about, has significantly strengthened and accelerated the ongoing search for extraterrestrial life. These organic molecules were found in the massive, cold, and dark dust clouds where new stars and planets are born. The undeniable presence of these carbon-based complex structures proves that the basic materials necessary for life to form are present in almost every corner of the universe. NASA researchers are continuing their intensive studies to better understand the formation and distribution processes of these vital molecules. This discovery has dramatically increased the likelihood that the necessary conditions for life could exist in many different parts of the universe. NASA will now explore more regions of space to analyze the diversity and distribution of these organic molecules in even greater detail. This could lead to even stronger and more direct evidence of life in different parts of the universe. Thanks to this discovery, scientists are increasingly supporting the theory that the universe is, in fact, a life-friendly environment. The existence of organic molecules may indicate that life is much more widespread and common in the universe than we had ever dared to hope. This means that our chances of one day making contact with extraterrestrial life are higher than ever before. The data from the James Webb Telescope has revealed that the universe is expanding much faster than scientists had previously calculated. These shocking results, which have plunged the entire scientific community into a state of deep confusion, indicate that our predictions about the ultimate fate of the universe need to be completely re-examined. The concept of dark energy, which is believed to be the cause of the increase in the expansion rate of the universe, has thus gained a much greater and more urgent significance. The expansion rate of the universe is considered one of the most fundamental parameters in all of cosmology, a value known as the Hubble constant. This parameter plays a critical role in our understanding of the age and ultimate expansion of the universe. The precise data provided by James Webb contains dramatic differences that could fundamentally change the accepted value of this constant. This indicates that the universe is not only expanding much faster than we previously thought, but that this expansion is also accelerating over time. Scientists have now begun to investigate the causes of this unexpected and rapid expansion. Among the leading theories is the idea that dark energy is far stronger and more widespread than we had previously thought. If this theory is confirmed, the ultimate fate of the universe, that it will continue to expand indefinitely and eventually end in a cold, dark state known as a Big Crunch, will gain significant traction. NASA has decided to accelerate new observations in this area to gather more data. Additional observations from the James Webb Telescope in the coming period will allow us to measure the expansion rate of the universe much more accurately. This could completely reshape all of our existing assumptions about the ultimate fate of the universe. This unexpected discovery could trigger a major and long-lasting paradigm shift in the field of cosmology. The James Webb Space Telescope recently made a surprising discovery of a new planetary system with strikingly Earth-like characteristics. The system hosts multiple planets located within its star's habitable zone, and at least one of these planets appears to have conditions that are highly suitable for life. Clear and undeniable evidence of both water vapor and oxygen was detected in the atmospheric analyses of one of these worlds. The sizes and positions of the planets in this newly discovered system provide the basic conditions necessary for life at almost ideal levels. Scientists have noted that the specific molecules observed in the atmospheric analysis could strongly indicate the presence of life forms on these planets. This could go down in history as a very strong and concrete example of the very real possibility of finding extraterrestrial life. NASA is now planning detailed and long-term observations to study the chemical composition of these planets' atmospheres in much greater detail. The James Webb Telescope's highly sensitive instruments can determine atmospheric composition and surface temperatures with an incredibly high degree of accuracy. This new planetary system will be at the very center of space research in the coming period and will give a completely new direction to the ongoing search for extraterrestrial life. If the existence of life on the planets in this system is confirmed, This discovery will be truly revolutionary in human history. NASA is, understandably, very excited about this prospect. Joint observations and research conducted internationally may reveal very important and paradigm-shifting data about this system in the coming years. The James Webb Space Telescope has obtained crucial and long-awaited evidence about dark matter, one of the universe's greatest and most enduring mysteries. During its observations, clear and unambiguous clues about the existence and distribution of dark matter were detected from the movements of stars and gas clouds in distant galaxy clusters. This discovery finally and powerfully confirms the long-held theories about dark matter and significantly deepens scientists' understanding of the fundamental structure of the universe. Dark matter, which has been observed indirectly by astronomers for many years but remains largely unexplained, accounts for approximately 85% of the universe's total mass. The data provided by the James Webb Telescope offers the clearest and most direct evidence to date of the existence and distribution of this mysterious and invisible substance. This represents a major step forward in our understanding of how the universe formed and how it has evolved over time. Although scientists cannot directly observe dark matter, they can clearly see its powerful effects. The data from the telescope determines the speed and movement of galaxies, and this motion powerfully confirms the existence of dark matter. This will now make it possible to map the distribution of the matter that holds all cosmic structures together throughout the entire universe. NASA will conduct more in-depth analyses of dark matter using additional data from the James Webb Telescope in the coming period. This will clarify the details of the dark matter theory and provide a much clearer understanding of how the large-scale structure of the universe was formed. This could represent a revolutionary advance in our understanding of the fundamental structure of the universe. The data provided by the James Webb Space Telescope has shown that our current scenarios regarding the ultimate fate of the universe need to be radically revised. In particular, the higher-than-expected rate of expansion of the universe and the stronger-than-expected effect of dark energy are reshaping all of our assumptions about the future of the universe. The scientific community now emphasizes the pressing need to revisit the long-held theories about the ultimate fate of the cosmos. While it was previously predicted that the universe would expand slowly and perhaps even collapse back in on itself at some point in the distant future, the new data from the James Webb Telescope has completely and utterly changed this picture. Scientists now believe that the universe may be expanding at an ever-increasing rate and could eventually lead to a cosmic-scale fragmentation, a scenario known as the Big Rip. This scenario suggests that the universe could transform into a completely different and unrecognizable structure in the distant future. Research conducted by NASA may reveal further findings that support this new and dramatic scenario. In particular, the data collected by the telescope about the very first moments of the universe is critical to understanding how this expansion will evolve in the future. Scientists are intensifying their efforts to obtain clearer data about the rate of expansion and the true nature of dark energy. With the data that the James Webb Space Telescope will provide in the coming years, our scenarios about the end of the universe will become much clearer and more precise. In light of this new data, the sections of our cosmology books about the end of the universe may be seriously and fundamentally rewritten in the near future. The images obtained by the James Webb Space Telescope have revealed the youngest galaxies in the universe. And these galaxies are not what scientists had expected at all. The fact that these young galaxies are much larger and more developed than had been anticipated has led us to question the most fundamental assumptions of our theories about galaxy formation. This single discovery has caused a profound and widespread shock in the entire field of astronomy. Previously, it was assumed that galaxies in the earliest stages of the universe were irregular, small, and very simple in their structure. However, The Webb telescope has revealed that these galaxies possess incredibly advanced and active star-forming regions. Scientists now believe that much more complex and rapid processes occurred in the earliest stages of the universe than we had previously thought. NASA has begun extensive analyses to understand the formation process and structure of these impossibly young galaxies. These analyses have revealed that the galaxies underwent extremely rapid and large-scale star formation processes. The fact that these galaxies are larger and more organized than expected has raised serious questions about how the diffuse clouds of gas and dust in the early universe could have organized themselves so quickly and efficiently. This discovery shows that the conditions in the early universe were much more dynamic and complex than we had ever thought. The striking data collected by James Webb may necessitate a complete rewriting of our cosmological theories. New research on galaxy formation and evolution in the early universe could change the entire history of astronomy in the future. The James Webb Telescope has unexpectedly discovered organic molecules that could be signs of life on an asteroid within our own solar system. The complex carbon-based molecules found on the asteroid's surface had never been detected so clearly within the solar system before. This astonishing discovery has revealed that asteroids could be potential habitats for extraterrestrial life, or at least the carriers of its essential ingredients. The molecules found on the asteroid's surface contain amino acids and other complex carbon compounds, which are known as the fundamental building blocks of organic life. This finding has significantly strengthened the possibility that life could emerge not only on planets, but also on much smaller celestial bodies. The discussions about the important role that asteroids may have played in the distribution of life throughout the cosmos have now been reignited with new and powerful evidence. NASA is now preparing new mission plans to confirm these signs of life on asteroids, based on the data provided by the James Webb Telescope. New space probes are being designed to collect physical samples from the asteroid's surface. The analysis of these samples could provide a much deeper and more profound understanding of the true origins of life. The importance of this discovery is not limited to astrobiology. It also makes it possible to consider asteroids as potential sources of life support that could be used in future space exploration missions. This could fundamentally change humanity's presence in space and our future colonization efforts. One of the most intriguing discoveries made during the James Webb Space Telescope's deep space observations was the identification of an incredibly large cosmic void in the universe. This massive void is hundreds of millions of light-years wide and contains almost no galaxies, stars, or even detectable matter. This astonishing discovery is shaking our fundamental understanding of the large-scale structure of the universe. Cosmic voids have been observed before, but finding an area of this immense size that is so completely and utterly empty was completely unexpected. Scientists are still unable to explain how this massive void could have formed. Its formation may be related to unknown factors, such as the behavior of dark energy or dark matter, which are believed to shape the large-scale structure of the universe. NASA has begun detailed studies to understand the nature of this massive void. The high-resolution infrared observations from the Webb telescope are helping to clarify the interaction of this void with the galaxy clusters that surround it. Scientists are working to understand why this void formed and why it is so starkly different from all other parts of the universe. This discovery may force us to rethink our current models of the structure of the universe. The existence of such giant cosmic voids suggests that we will have to reinterpret the processes of the expansion and distribution of matter throughout the entire universe. The data provided by the Webb telescope could reshape the future of all of our cosmological theories. The new images obtained by the James Webb Space Telescope reveal that the processes of planet formation are much more complex and varied than we had previously thought. The new findings show unexpected structures and complex chemical compositions in the planet-forming disks of gas and dust that surround young stars. This suggests that planets may have formed in ways that are very different from what our traditional theories have described. Previous theories suggested that planets formed through the simple and gradual accumulation of gas and dust clouds orbiting young stars. However, the incredibly detailed images from the Webb telescope show that planet formation involves much more complex chemical processes and rapid, dramatic changes. Unexpected gas movements and complex chemical reactions have been discovered during the very formation of these young planets. NASA's new discovery is triggering a major paradigm shift in the fields of planetary science and cosmic chemistry. We are now forced to completely re-examine how and at what speed planets form. The detailed images and spectral analyses provided by the Webb telescope are enabling us to completely redefine the intricate processes of planetary formation. This discovery requires us to re-evaluate our entire understanding of the formation and evolution of planets outside our own solar system. As a result, new theories could emerge that will fundamentally alter our assumptions about planet formation and the distribution of potentially habitable planets throughout the entire universe. The James Webb Space Telescope has detected a series of unusual celestial objects moving at incredible speeds in the most distant regions of the universe. The speeds of these objects far exceed those of all previously observed astronomical objects, raising serious and troubling questions in the minds of astronomers. Scientists are currently unable to fully explain how such extreme speeds could have been achieved. And the situation has put NASA on high alert. Some of these fast-moving objects are observed moving at incredibly high speeds away from the centers of their host galaxies. This suggests that these objects may be associated with extraordinary and violent cosmic events, such as interactions with supermassive black holes or massive asymmetric explosions. However, this theory has not yet been fully proven. Research is now being conducted intensively using the high-resolution data obtained by the Webb telescope. NASA research teams have begun studying the paths that these celestial objects take and the environments around them to understand why they are moving so incredibly fast. If these high speeds are caused by a completely unknown and new astronomical phenomenon, this discovery could represent a major breakthrough in the field of astronomy. For this reason, scientists are conducting various observation campaigns to analyze these objects in much greater depth. The extraordinary data collected by the James Webb telescope could help us to understand previously unknown physical processes in the universe. Once the mystery behind these incredible speeds is finally solved, we may gain revolutionary new insights into critical topics, such as the distribution of energy and the evolution of galaxies throughout the universe. The James Webb Space Telescope has discovered the oldest known star, an object that was formed in the earliest stages of the universe. This ancient star, which formed approximately 13.7 billion years ago, is a very rare and precious object that reflects the very first light of the universe. The discovery of this star has generated great excitement in the scientific community, as it may reveal important and long-hidden information about the earliest stages of the universe. The chemical composition and brightness of this ancient star provide scientists with clear clues about how the very first stars in the universe formed and how they evolved. The extremely low abundance of metals observed in the star's atmosphere confirms that it was formed in the very early stages of the universe. From the primordial gas of the Big Bang, NASA aims to conduct detailed analyses of this star to better understand these earliest stages of the universe. Scientists believe that observing this ancient star could finally answer some of the long-standing questions about the first stars and galaxies in the universe. The star's unique characteristics could provide critical information about the distribution and density of matter in the early universe. This information could significantly alter our existing theories about the universe's earliest and most mysterious stages. This discovery by the James Webb Telescope is seen as a major turning point in the field of astronomy, pushing back the boundaries of what is known about the history of the universe. This discovery is considered one of the most important findings in all of cosmological history. The new data from the James Webb Telescope suggests that the overall geometry of the universe may be different from what the scientific community has long accepted. While previous cosmological models have assumed that the universe is almost completely flat on the largest scales, the data from the Webb telescope shows that the universe may have a different and more complex shape. These new findings are seriously challenging the most fundamental assumptions in the entire field of cosmology. Scientists were able to measure the large-scale structure of the universe much more accurately by analyzing the light data collected by the Webb telescope. The results suggest the very real possibility that the universe may not be perfectly flat, but instead slightly curved or even closed in on itself. Such a geometric structure could significantly affect the expansion rate of the universe and the distribution of matter within it, thereby altering the ultimate fate of the universe. NASA is now conducting large-scale observations using the Webb telescope's advanced capabilities to obtain clearer data about the true geometry of the universe. In particular, the study of the cosmic microwave background radiation is critical to clarifying the overall and fundamental geometry of the universe. If they are confirmed, these new findings could be truly revolutionary in the field of cosmology. These new findings about the geometry of the universe could fundamentally change our most basic cosmological principles and our theories about the future of the universe. Based on this new data, our predictions about the fate of the universe could change significantly, and many of the fundamental theories in cosmology may need to be completely rewritten. The James Webb Space Telescope has clearly and directly observed the effects of dark energy, one of the greatest and most profound mysteries in all of cosmology. These new observations, which provide concrete and undeniable evidence of how this mysterious energy is increasing the expansion rate of the universe, have caused a major and excited stir in the scientific community. The effects of dark energy, which had previously only been estimated indirectly through its influence on distant supernovae, have now been observed clearly and directly for the very first time. Dark energy accounts for approximately 68% of the total energy budget of the entire universe, but its true nature remains largely unknown and mysterious. Webb's high-resolution observations have enabled scientists to clearly track the effects of this energy on the movements of distant galaxies and entire galaxy clusters. This marks a significant and historic milestone in confirming the very existence of dark energy. NASA research teams are now using the critical data obtained by the Webb telescope to try to understand the true nature of this dark energy. Questions about how this energy works and how it is able to accelerate the expansion of the entire universe are among the most important and pressing research topics in modern cosmology. With these new and precise observations, our theories about dark energy are growing stronger and more diverse. The clear visualization of the effects of dark energy is an important milestone in the entire history of cosmology. Thanks to these observations, our predictions about the ultimate fate of the universe may soon become much more accurate and reliable. The latest images obtained from the James Webb Space Telescope have revealed that the process of galaxy formation is much different than we had previously thought. Previous theories had assumed that galaxies formed slowly over vast periods of time through the gradual merging of small gas and star clusters. But the incredibly clear and detailed images provided by Webb show that galaxy formation is a much more complex, chaotic, and diverse process. This new understanding has caused significant astonishment and debate in the entire field of astronomy. In particular, the fact that galaxies that formed in the early universe exhibit much faster and more complex structures than had been expected renders all of our current models completely inadequate. The observed star formation rates and the rapid chemical evolution of these early galaxies do not align with our previously accepted models. This new situation necessitates the urgent development of new theories to explain the processes of galaxy formation. NASA scientists are now analyzing the data from the James Webb Telescope in great detail to better understand this different and more rapid formation process. The goal is to clarify the physical processes and the interactions of matter that the galaxies experienced in their earliest stages. This will provide a much more solid and realistic foundation for our understanding of how galaxies are born and how they evolve over time. These new findings will completely reshape our theories about galaxy formation and evolution in the early universe. The high-quality images and spectral data provided by the James Webb Telescope could trigger one of the greatest paradigm shifts in the entire history of astronomy and mark a critical turning point in our understanding of the cosmic evolution of the universe. The data recorded by the James Webb Telescope includes unexpected and massive explosions in star systems that are relatively close to Earth. The immense size and energy of these explosions are deeply challenging scientists' current theories about the processes of stellar evolution. This has become a major cause for concern for NASA and has necessitated a serious and urgent reevaluation of the potential for unexpected explosions in the stars within our own cosmic neighborhood. These sudden and violent explosions observed in nearby stars are believed to stem from causes that do not align with our classical models of stellar evolution. These explosions, which are typically expected to occur only during very specific stages of a star's life, are now being seen at unexpected times and with unexpected intensity. The telescope's sensitive infrared sensors provide the unique opportunity to observe the dynamic processes that are occurring inside these stars much more clearly. This new data could lead to the development of completely new theories that can explain the unexpected and sometimes violent behavior of stars. The detailed study of these types of explosions could fundamentally change our entire understanding of the life cycle of stars. It is also critical for assessing the habitability of planets in nearby star systems and for understanding the potential cosmic risks that the Earth may face in the future. The explosions observed by the Webb Telescope could open a completely new and exciting chapter in the fields of stellar science and astrophysics. One of the most striking observations made by the James Webb Telescope was an extraordinary and high-energy explosion that originated from the deepest reaches of space. This single explosion occurred at energy levels that far exceeded anything that had ever been previously recorded, leaving scientists utterly and completely baffled. The cause of this explosion remains completely unknown, but astronomers believe that it could potentially alter our entire understanding of the universe's most extreme energy release processes. The source of this massive energy burst could be a galaxy-scale event, something involving the entire structure of a galaxy. Some theories suggest that the burst is related to the merger of two supermassive black holes or a new type of massive supernova explosion. However, even our existing theories struggle to explain energy emissions of this incredible magnitude, and scientists are now in need of completely new theories to explain this powerful phenomenon. NASA is now analyzing all of the data collected by the James Webb Telescope in great detail to understand the specifics of this high-energy explosion. These analyses will help us to better understand the source of the explosion, the mechanism of its energy formation, and its powerful effects on its surrounding environment. The international astronomy community is also showing intense and focused interest in this extraordinary event, and additional observations from many different telescopes are now being planned. The explanation of this single explosion could be a critical turning point in our understanding of the most energetic events in the entire universe. The new data from the James Webb Telescope has overturned our classical theories about the death of stars. In particular, it has been revealed that the supernova explosions that occur at the end of the lives of massive stars go through stages that are very different from what we had previously thought. This new understanding has caused such a stir in the scientific community that it will require the complete rewriting of our models of star evolution. According to the new findings, some stars release energy in completely unexpected ways at the very end of their lives and undergo complex and dramatic structural changes just before the final explosion. The Webb telescope's precise and detailed observations have clearly documented the unexpected physical and chemical processes that are occurring during the pre-explosion stages of these stars. These complex processes were not predicted by any of our existing theories of star evolution. NASA is now conducting detailed observation campaigns to confirm these unexpected findings and to better understand the final, dramatic stages of stars. These new studies will provide a much clearer and more detailed understanding of the complex processes that are occurring during the death of these stars. This could significantly alter our understanding of stellar evolution, which is one of the most fundamental concepts in all of astronomy. These unexpected findings from the James Webb Telescope are now causing serious questions about our existing theories on the death of stars and the chemical evolution of entire galaxies. The images obtained by the James Webb Space Telescope include important and groundbreaking findings about the very first moments of the universe. These images show that the distribution of matter at the very beginning of the universe was much more chaotic and clumpy than had been expected. Scientists now say that the physical processes that took place in the first moments of the universe were very different from what had been previously assumed, and that these new findings could fundamentally change our most basic cosmological theories. According to our known cosmological theories, the universe underwent a process of rapid expansion just after the Big Bang, and matter was expected to have spread out in a relatively specific and uniform order. However, the incredibly detailed images from the Webb telescope reveal that these initial moments were far more complex, chaotic, and completely unexpected. These new details from the first light of the universe have prompted scientists to completely reevaluate the standard Big Bang theory. NASA is now conducting intensive research to better analyze these surprising images and to understand the true initial conditions of the universe. The new data provided by James Webb contains the clearest and most detailed observations of the universe's first moments to date. In light of this new information, more realistic and accurate models of the physical processes that occurred during the universe's initial phase can now be developed. Thanks to this discovery, our efforts to understand the processes that took place in the first moments of the universe are now taking on a completely new dimension. A mysterious object detected during the deep space observations by the James Webb Space Telescope has caused a significant stir in the entire astronomy community. This strange object does not fit into any known category of astronomical objects, and its unusual characteristics have plunged scientists into a state of deep and profound confusion. Astronomers have not yet been able to determine exactly what this object is and are now considering a wide variety of different theories. This mysterious object is emitting unexpected and highly periodic signals and is moving at an astonishingly high speed. Some scientists speculate that it could be a known phenomenon, like a neutron star or a pulsar, but with some unusual properties. However, the object's movement and its unique signal characteristics are significantly different from all known astronomical objects. Therefore, it is possible that a completely new type of cosmic object has been discovered. NASA researchers are now utilizing the James Webb Telescope's advanced technological capabilities to better understand the properties of this mysterious object, based on the data that has been obtained. It is anticipated that more robust and testable hypotheses regarding the object's origin, its composition, and its mechanism of movement will be developed in the near future. The identification of this strange object could even lead to the creation of a completely new category in the field of astronomy. The observations made by the James Webb Telescope have shown that the levels of cosmic radiation in deep space are much higher than had been previously estimated. These high and pervasive radiation levels could have significant and far-reaching effects on the processes of star formation and galaxy evolution in various regions of the universe. Astronomers are now trying to understand the source of this unexpected and dramatic increase in radiation. Cosmic radiation is typically associated with high-energy events such as supernovae, the collisions of stars, and the activity of supermassive black holes. The data from Webb is now allowing clearer and more precise information about the sources and the propagation processes of this radiation to be obtained. These new studies may lead to a much better understanding of the effects of cosmic radiation on the overall structure and evolution of the entire universe. The higher-than-expected levels of cosmic radiation could also have important and serious implications for future space exploration and for human space travel. NASA may now have to completely reassess the levels of radiation that astronauts will be exposed to in light of these new and unexpected findings. Thus, this unexpected discovery could fundamentally change both the field of astronomy and our future strategies for space exploration. The new data from the James Webb Space Telescope has reignited the long-standing scientific debate about the concept of the center of the universe. While our traditional cosmological models have long assumed that the universe has no distinct or special center, the data from the Webb telescope has revealed unexpected and significant increases in density in certain large-scale regions of the universe. This new finding has opened up fundamental and profound questions about our entire understanding of the structure of the universe. The images provided by the Webb telescope reveal that some of the large-scale cosmic structures exhibit a different and more complex dynamic from the general expansion of the universe. These specific regions have much higher densities of both matter and energy when compared to all other areas. Scientists are now actively debating whether these unusually dense regions could provide new clues about the true center of the universe. NASA researchers have now launched a comprehensive and long-term study to understand the nature and the structure of these dense regions. Thanks to the advanced technology of the Webb telescope, detailed spectral and chemical analyses of these specific regions are now being conducted. This will enable a much more robust and accurate assessment of the large-scale structures of the universe and the ongoing debates surrounding its potential center. This unexpected discovery could lead to a fundamental and long-lasting paradigm shift in the field of cosmology. The James Webb Space Telescope has uncovered surprising and completely new findings about our own galaxy, the Milky Way. The detailed observations from the telescope reveal that the Milky Way has a much more complex and different structure than we had previously thought. The arrangement of the spiral arms, the density of the central region, and the distribution of dark matter around the Milky Way do not align with the models that scientists had previously anticipated. The images of the Milky Way's central region show previously unknown rings of gas and stars that are orbiting around the supermassive black hole at its very center. The existence of these rings proves that the evolution of our own galaxy is far more complex and dynamic than we had previously thought. Additionally, the distribution of the dark matter clouds that are surrounding the galaxy also exhibits unexpected and significant differences when compared to our previous models. NASA is now intensively analyzing these new findings that have been provided by the Webb telescope in order to gain a much deeper and more accurate understanding of the true structure of the Milky Way. Based on this new data, New theories will now need to be developed to explain the dynamic and complex processes that are occurring within our own galaxy. This new situation is now leading to a complete re-examination of all of our traditional assumptions about the formation and the evolution of the Milky Way galaxy. The analyses conducted by the James Webb Telescope have revealed unexpected chemical compositions and complex structures in the atmospheres of distant planets. Our previous assumptions had suggested that the atmospheres of planets were mostly composed of relatively simple chemical structures. But the detailed spectral analyses that have been provided by the Webb telescope indicate that these atmospheres are, in fact, unexpectedly complex and dynamic. Among these unusual molecules that have been found in these planetary atmospheres are complex organic compounds and various gases that could potentially be interpreted as signs of life. These new findings suggest that the necessary conditions for life in the universe may be much more widespread than we had previously thought, and that the processes of chemical evolution in planetary atmospheres are far more dynamic and creative than we had imagined. NASA researchers are now conducting detailed and long-term studies to understand the origin of these unexpected components that have been detected in these planetary atmospheres. The critical question of whether these molecules that are associated with life are of a biological origin or are simply the result of abiotic, non-living processes is now gaining a much greater importance in the scientific community. The Webb telescope's advanced technology and its highly sensitive sensors are helping us to understand these atmospheric compositions much more clearly and with a much greater degree of certainty. The James Webb Space Telescope has both stunned and alarmed the entire scientific community by clearly imaging massive and violent star collisions that are occurring in some of our nearby galaxies. The immense and overwhelming energy and radiation that are being emitted during these collisions far exceed anything that astronomers have ever observed before. It has now been revealed that these star collisions are occurring much more frequently than we had ever expected, and that they are having far more dramatic and far-reaching effects on their surrounding environments. The intense and powerful radiation that is being produced by these colliding stars can significantly affect the surrounding planets and star systems. This suggests that these star collisions may have a critical and previously underestimated impact on the distribution of matter throughout the entire universe, on the processes of planet formation, and even on the potential for life to emerge and survive. It is now understood that such violent events are much more important and common astronomical processes than we had ever previously thought. NASA is now planning extensive and long-term observations to study these star collisions in much greater depth and to better understand their powerful effects and their true frequency. The precise and detailed data that has been provided by the James Webb Telescope will now enable a much more detailed and accurate analysis of the internal structure of these colliding stars, their powerful energy emissions, and their wide-ranging effects on their surrounding environments. One of the most exciting and significant discoveries of the James Webb Space Telescope was the identification of a distant planet that is covered with water and is very similar to our own Earth. The presence of abundant and liquid water on the surface of this planet has been confirmed, which has raised great and widespread hopes in the ongoing search for extraterrestrial life. This unique planet is located within its star's habitable zone, and its atmosphere appears to provide the necessary conditions for life to exist and to thrive. The presence of liquid water on this planet's surface is considered to be one of the most critical and essential factors for the formation of life as we know it. The atmospheric analyses from the Webb telescope have also revealed the presence of some of the most basic and fundamental life indicators, such as oxygen, carbon dioxide, and methane, on this distant planet. These combined findings greatly and significantly increase the likelihood of finding various forms of life on this unique and promising planet. NASA has now begun extensive and long-term studies of this Earth-like planet. and aims to investigate its atmospheric structure and its surface in much greater detail with a series of future space missions. The powerful and precise data that is being provided by the Webb telescope is strong enough to potentially answer the question of whether life truly exists on this planet in the very near future. The detailed analyses that have been conducted by the James Webb Space Telescope have revealed that the chemical composition of the cosmic dust clouds in space is significantly different from what scientists had previously anticipated. According to our traditional theories, cosmic dust is generally assumed to consist of very simple carbon and silicon-based molecules. However, the spectral data from the Webb telescope has revealed that these tiny dust particles contain much more complex and varied structures. The presence of a wide range of organic molecules in these cosmic dust clouds at this unexpected level of complexity once again highlights just how widespread the fundamental building blocks of life are throughout the entire universe. Additionally, the complex and varied structure of these dust clouds could significantly and directly influence the formation processes of both stars and planets. This new finding is now prompting astronomers to completely reevaluate their entire understanding of the processes of both star and planet formation. NASA has now begun extensive and detailed analyses to understand the source and the effects of these unexpected and significant findings in the composition of this cosmic dust. Thanks to the new and precise data that has been obtained by the Webb telescope, the complex and intricate chemical reactions that are occurring within these dust clouds can now be much better understood. The James Webb Space Telescope has made surprising and completely new discoveries by observing the structure of space-time in an unprecedented level of detail. The precise observations from the telescope show that the light that is traveling around the massive galaxy clusters in the most distant regions of the universe is bending in a way that is different from what had been expected. This new finding could now lead us to completely re-examine Albert Einstein's famous theory of general relativity and the most fundamental principles of the curvature of space-time. The Webb telescope's precise and detailed lensing observations reveal that the curvature of space-time around these distant galaxies does not fully align with our previously calculated and long-accepted models. This could indicate either significant differences in the distribution of dark matter or the presence of previously overlooked elements in our most fundamental gravitational theories. These new and unexpected findings are now seriously challenging some of the most basic and long-held theories in the fields of both physics and cosmology. NASA researchers have now launched an intensive and long-term effort to understand the causes of these unexpected and significant findings. The Webb telescope's high-resolution observations will now enable a much more accurate and detailed mapping of the distribution of both matter and energy throughout the entire universe. The data from the James Webb Space Telescope contains clues that are so powerful that they are now calling into question all of the predictions that scientists have made about the future of the universe. In particular, the new and detailed information that has been obtained about the rate of the expansion of the universe and the powerful effects of dark energy have now led to the emergence of completely new and different theories about the ultimate and final fate of the universe. Scientists now believe that the images from the telescope may allow us to see the future of the universe with a much greater degree of clarity. According to the new data that has been received from the telescope, the rate of the expansion of the universe may be much higher than had been previously expected, and the powerful effect of dark energy may be much stronger. This could mean that the universe will continue to expand and will eventually break apart, or that the large-scale cosmic events that are yet to come will be much more dramatic and violent than had been previously anticipated. The Webb telescope's ongoing observations are now enabling these new and dramatic scenarios to be scientifically and rigorously evaluated. NASA is now using the James Webb Telescope's immense data collection capacity to its fullest extent in order to clarify this critical and vital information about the ultimate fate of the universe. The observations that have been made by the James Webb Telescope have now revealed a new and completely unexpected cosmic phenomenon that appears to be preventing the formation of planets in certain regions of space. It has been discovered that the intense and powerful radiation and the extremely strong magnetic fields that are present in the gas and dust disks that are surrounding some young stars are seriously and significantly hindering the process of planet formation. This new discovery could now fundamentally change all of our existing and long-held theories about the very processes of planet formation. According to our previous theories, it was expected that the disks of gas and dust that are surrounding young stars would provide the necessary and ideal conditions for the formation of planets. However, the new and precise data from the Webb telescope now shows that the extreme and powerful radiation and the intense magnetic activity that are present in certain regions of these disks are actually preventing the accumulation of matter, which is making the formation of planets in these regions completely impossible. This new finding now challenges our entire understanding of the distribution and the total number of planets that exist throughout the entire universe. NASA researchers are now conducting detailed and long-term analyses to better understand the causes and the true scope of this newly discovered phenomenon. The James Webb Space Telescope has detected the strongest and most powerful magnetic field that has ever been recorded in the deepest reaches of space. This immense and powerful field is millions of times stronger than the Earth's own magnetic field and covers an extraordinarily large and extensive area of space. This new and unexpected discovery has now forced us to completely rethink the absolute limits of the physical forces that can exist in the universe, and has made it necessary for us to examine the critical role that magnetic fields play in the evolution of celestial bodies much more closely. This massive and powerful magnetic field is thought to originate from a neutron star, which is one of the densest and most extreme objects that is known to exist in the entire universe. However, this particular field extends over a much larger and more extensive area than a normal neutron star, which indicates the presence of a previously unobserved and completely unknown structure. Scientists are now working to understand how this incredibly powerful magnetic field is affecting the surrounding interstellar matter, and how it is shaping the very fabric of the space-time that surrounds it. NASA has now begun to map this extraordinary and powerful magnetic region in great detail. By using the data that has been provided by the James Webb Telescope and by studying its powerful effects on the nearby stars, the gas clouds, and the various galactic structures that are in its vicinity. The atmospheric analyses that have been conducted by the James Webb Telescope have now detected the very chemical compounds that are essential for life in the atmospheres of multiple and distant planets. The precise ratio, the complex structure, and the wide distribution of these particular molecules have now led scientists to develop strong and compelling hypotheses about the very real and possible existence of extraterrestrial microorganisms. These new and exciting findings are now considered to be one of the most concrete and significant steps that have ever been taken in the long and ongoing search for extraterrestrial life. The undeniable presence of methane, ammonia, and oxygen in the atmospheres of these analyzed planets strongly suggests that these particular substances may have been produced by living organisms. This is now considered to be one of the strongest and most compelling clues that is indicating the presence of ongoing biological activity. Such clear and consistent results have never been obtained before in the entire history of astronomy. NASA is now conducting further and much more detailed observations of the atmospheres of these particular planets in order to determine whether these biological traces are indeed from living microorganisms. If it is confirmed that these molecules do have a biological origin, then it would mark the very first time in all of human history that clear and undeniable evidence of life has been found beyond our own Earth. The James Webb Telescope has detected unusual and surprising activity in the central regions of many different galaxies. The density of both the matter and the energy emissions in these particular regions were much higher than scientists had ever anticipated. This new and unexpected activity that is occurring around the supermassive black holes at the very cores of these galaxies is now raising completely new and different questions about the true and dynamic nature of the entire universe. While the centers of galaxies are typically expected to be much more stable and static, the new observations from Webb have revealed that these particular regions are, in fact, filled with violent and chaotic cosmic storms. It was found that the gas and the dust clouds that are surrounding these supermassive black holes are moving at incredibly high speeds, with their light and their energy emissions reaching extreme and unprecedented intensities. This now suggests that these black holes are far more active and dynamic than we had ever previously thought. NASA has now begun to conduct detailed and long-term spectral analyses to better understand the true nature of the activity that is occurring in these galactic centers. The data that has been obtained now shows that these black holes are not just simple structures that are swallowing up matter, but are also highly dynamic and powerful centers that are emitting large and significant amounts of both energy and radiation back out into their surrounding environments. The James Webb Telescope has now discovered massive and extensive water vapor clouds in the deepest reaches of space, in the vast and empty interstellar void. These new and unexpected findings now reveal that water, which is one of the most fundamental and essential components of life as we know it, is much more widespread and common in the universe than we had ever previously thought. Water, which was previously only found on planets and on some comets, has now been detected even in the vast and empty intergalactic void. These newly discovered water vapor clouds are particularly concentrated in the regions where new stars are forming and may be playing an important and previously unknown role in the very formation of these stars. The data that has been obtained by Webb has now clearly revealed the precise chemical composition and the temperature levels of these particular clouds. This has now enabled much more accurate and detailed interpretations of where this water vapor originally came from and how it has managed to spread throughout the entire universe. NASA is now studying the dynamics and the movement patterns of these clouds in order to better understand how water is able to circulate throughout the entire universe. These new findings will now enable much more accurate and precise predictions about where the planets that are capable of supporting life could potentially form in the future. The observations that have been made by the James Webb Space Telescope have now fundamentally challenged our entire understanding of the red giant stars that are in their final and dramatic stages of evolution. Previously, it was believed that the outer shells of these particular stars simply expanded and cooled while their inner cores contracted in a steady and predictable manner. However, the new and precise data that has been collected by Webb has now revealed that the surface activity and the amount of material that these stars are emitting into their surrounding environments are much more irregular and complex than had ever been expected. Thanks to the telescope's highly sensitive infrared detectors, the gas and the dust clouds that are surrounding these red giant stars have now been examined in much greater and more extensive detail. These clouds are formed as a result of the explosive and violent outbursts of material that occur as these stars are approaching the very end of their lives. However, the intermittent and highly irregular nature of these particular ejections has now revealed that the energy processes that are occurring deep inside these stars have a much more unstable and chaotic structure than had been previously thought. This new and unexpected finding has now necessitated a major and significant revision of all of our existing models of stellar evolution. The James Webb Space Telescope has now detected a massive and extensive gas cloud of a completely unprecedented and unknown type in a very distant and remote corner of space. The chemical composition, the precise location, and the high density of this particular cloud deviates significantly and dramatically from what scientists had previously expected. while such large and massive structures are typically dominated by the simple elements of hydrogen and helium. This particular structure appears to contain much heavier elements and various other unknown and mysterious components. This time, the infrared spectrum data that has been obtained from the Webb telescope now indicates the presence of intense and powerful energy transfers that are occurring at the very center of this particular gas cloud. This now suggests the very real and possible presence of a completely hidden and previously unknown energy source, which is perhaps an as of yet undefined and completely new type of astronomical object. NASA scientists are now conducting extensive and detailed analyses across the entire electromagnetic spectrum in order to uncover the true and mysterious nature of this particular cloud. While the formation mechanism of such massive and extensive gas structures remains very poorly understood, the new discovery that has been made by Webb has now sparked a significant and widespread interest in the entire scientific community. The cosmological scale data that has now been obtained by the James Webb Telescope is providing us with significant and powerful clues about the ultimate and final fate of the entire universe. The detailed and precise analyses of various parameters, such as the movements of the distant galaxies, the rates of their expansion, the distribution of their matter, and the powerful and mysterious effects of dark energy are now presenting us with strong and compelling scenarios about the inevitable and final destiny of the entire universe. This new and unexpected situation is now being interpreted as the telescope showing us the very end of the universe in a very real and tangible sense. The incoming data now clearly and undeniably shows that the universe is not only expanding, but that it is also accelerating its expansion over time. This new and unexpected finding has now led to the serious and widespread consideration of a dramatic and catastrophic scenario that is known as the Big Rip, in which the entire universe will eventually tear itself apart and will ultimately cease to exist. While this particular scenario was previously only considered to be a theoretical and remote possibility, it is now being seen as a much more likely and probable outcome in light of all of the available and new data. The James Webb Telescope has now documented previously unrecorded and completely unexpected events, while it was observing the powerful and dynamic interaction between two large and colliding galaxies. The massive and powerful gas flow that is occurring between these two galaxies, the violent and dramatic star explosions that are being triggered by their collision, and the powerful and chaotic magnetic field collisions have all significantly and fundamentally challenged the entire understanding that scientists have of the processes of galaxy evolution. In particular, the new and vibrant star-forming regions that have emerged during these particular collisions were much more active and intense than had ever been expected. The massive and dense star clusters that have been formed after these galaxy collisions are now acting like massive and powerful star factories. And this entire process is beginning just a few million years after the two galaxies have merged together. However, the new and precise data from Webb has now revealed that the intergalactic gases have unexpectedly and dramatically merged together and have created intense and powerful energy fields during this particular process. Such powerful and dynamic interactions had never been observed clearly enough with any of our previous and less powerful telescopes. The observations that have been made by the James Webb Space Telescope of the distant and massive galaxy clusters have now revealed the very real and possible existence of previously unknown and highly dense regions that are located within these massive and extensive structures, which could now be accurately described as being cosmic cities. In these particular and unique regions, the galaxies are all clustered together in a very high density and closely packed pattern. However, what is truly and utterly astonishing is the fact that the rates of star formation in these particular and clustered areas have now reached extraordinary and unprecedented levels. And the levels of energy that are being emitted are also unexpectedly and dramatically high. The new and precise spectral analyses that have been conducted by Webb have now shown that these cosmic cities are not only physically very close to each other, but that they are also strongly and powerfully interacting with each other in terms of the flow of their matter, the intensity of their radiation, and the transfer of their gas. This new and unexpected finding has now shown that the galaxies are affecting each other not only in a gravitational sense, but also in an energetic and dynamic sense. The powerful and far-reaching effects of such massive and extensive structures on the processes of galaxy evolution have not been sufficiently and properly considered until now. The James Webb Telescope has now shown that the levels of cosmic radiation that have been measured in the vast and empty intergalactic space and around some of the distant and remote star systems are much higher and more intense than had ever been previously expected. This new and unexpected finding is critical not only for the field of astrophysics, but also for the future of human health and for all of our future plans for space travel. The fact that the levels of radiation in space are so incredibly intense and constant now poses a very serious and significant threat to the future of humanity, as we are now planning for long-term and extensive space missions. The high energy and powerful particles that are present in these intergalactic regions, in particular, could now pose a very significant and serious risk to all of our spacecraft and to all of our astronauts who will be traveling through the vast and empty interstellar medium. The new and precise data that has been obtained from the James Webb Space Telescope now suggests that this powerful and pervasive radiation may be originating not only from the distant and remote stars, but also from the sudden and violent energy releases that are occurring around the supermassive black holes, from the remnants of the ancient supernovae, and from the very active and dynamic galactic cores. The groundbreaking and revolutionary images that have been sent back from the deepest reaches of space by the James Webb Telescope now contain new and incredibly detailed information that will undoubtedly shake many of the long-held and deeply ingrained theories that we have about the very formation of the entire universe. In particular, the clear and precise imaging of the very first galaxies and the most ancient structures from the first few 100 million years that followed the Big Bang has now revealed that the distribution of matter and the very formation of the galaxies during this particular and early period were much different and more complex than we had ever previously thought. The scientific community had previously, and for a very long time, argued that the universe had begun with only very scattered, highly disordered, and incredibly small structures. However, the new and incredibly detailed images that have now been sent back by Webb now suggest that even at that very early and primordial time, large and highly organized galaxies and very complex and intricate star systems may have already been formed. This new and unexpected finding has now necessitated the complete reconstruction of all of our computer models of the universe's earliest and most mysterious stages, and has now laid the very foundation for completely new and different theories that could now completely and utterly reshape the entire history of science. Supernovae, which are the massive and violent explosions that occur at the very end of a star's long and complex life, have long been one of the most fascinating and mysterious phenomena in the entire field of astronomy. However, the new and incredibly detailed observations that have now been made by the James Webb Telescope have now revealed that these particular and dramatic explosions are not just limited to the final and catastrophic release of energy, but that they are also preceded by a series of very complex and intricate physical processes. These new and unexpected findings could now lead to a complete and utter redefining of how all supernovae are actually formed. The high-resolution and incredibly detailed data that has now been obtained by Webb has now shown that intense and powerful gas outflows, sudden and dramatic temperature changes, And various and complex light fluctuations have all begun to occur months, and in some cases, even years before the final and catastrophic supernova event. This new and unexpected finding now suggests that supernovae are actually triggered by a very slow, highly complex, and gradual collapse process. The final and dramatic moment of the explosion may simply be the final and ultimate culmination of this very long and intricate process. One of the most intriguing and mysterious structures that has been encountered by the James Webb Space Telescope during its ongoing and detailed observations of the most distant and remote galaxies was a massive and extensive spiral form that is existing on a truly cosmic scale. However, these particular and unique spiral structures do not seem to resemble any of the ordinary and well-known galaxies. They are now being described as being highly unusual and mysterious forms that are composed of a series of intertwined and complex arms of both energy and dust. And they are completely lacking a distinct and well-defined stellar core at their very center. Scientists now believe that these particular and unique structures may be directly related to the powerful and dynamic energy flows that were occurring in the very early and primordial universe. These massive and extensive spiral structures may have been formed through the complex and intricate organization of the density of the interstellar matter and the various and powerful electromagnetic field lines in a very specific and unique pattern. However, these particular and unique structures are so incredibly large and distinct that they are now exhibiting a form of geometry that is far too complex to be explained by any of the known and well-understood local magnetic effects alone. The various and detailed observations that have now been made by the James Webb Space Telescope may now be heralding a new and theoretical step that could one day make the very real and possible prospect of interstellar travel a tangible reality for all of humanity. The new and precise data that has now been obtained from the telescope has now revealed the very real and possible presence of a series of unique and mysterious structures in certain and specific regions of space-time that are now exhibiting a series of strange and unexplained anomalies in the density of their matter and in the flow of their energy. These particular and unique anomalies now strongly suggest the very real and possible existence of a type of natural and occurring space-time tunnel. In theory, in these particular and unique tunnel-like regions, the very way that light is able to bend and to interact with matter is completely and utterly different. If these particular and unique areas do, in fact, truly contain a series of hidden and secret pathways that are able to allow for the very real and possible prospect of travel over vast and immense distances with a very minimal and negligible amount of energy, then this could now pave the very way for the very real and possible development of a new and revolutionary technology that will be able to enable the very real and possible prospect of interstellar travel in the very near and distant future, in one of the darkest and most remote regions of the entire universe, where the James Webb Telescope has now turned its powerful and unblinking gaze. A series of completely unexpected and still unidentified objects have now been discovered. This particular and unique region had never been imaged in any great and extensive detail by any of the previous and less powerful telescopes in the entire past, because it was previously thought to be almost completely and utterly devoid of both light and matter. However, thanks to the powerful and highly sensitive infrared capabilities of Webb, this particular and unique area has now emerged as if it were a completely new and different universe. The light that is being emitted by these particular and unique objects does not seem to match that of any of the known and well-understood stars, galaxies, or quasars. Their unique and mysterious emission characteristics may be originating from a series of super-dense and powerful energy fields, or from a series of completely new and different objects that are composed of a type of exotic and unknown matter, Scientists are now speculating that these particular and unique objects could be the ancient and long-lost remnants of a series of primordial and ancient black holes, or that they could be completely new and different forms of matter that have never been seen or even imagined before. A massive and powerful energy explosion was recently recorded in the deepest and most remote reaches of space. The James Webb Space Telescope has now detected one of the largest and most powerful energy explosions that has ever been recorded in a very distant and remote corner of the entire universe. Although the true and mysterious source of this particular and unique event has not yet been clearly and definitively identified. The total amount of energy that was observed was many and multiple times greater than that of a typical and well-understood supernova explosion. Scientists are now suggesting that this immense and powerful energy may have originated from a location that is very near to a supermassive and powerful black hole, or that it may even have come from a type of galactic core activity that is extremely and incredibly rare in the entire universe. This new and unexpected discovery now suggests that the various and complex energy production mechanisms that are at work in the entire universe may be much more complex and varied than we had ever previously thought. The powerful and highly sensitive infrared sensors of the telescope have now clearly and definitively recorded how the matter that was surrounding this particular and unique explosion was dispersed at speeds that were very close to the very speed of light in just a single and fleeting instant. Thanks to the powerful and highly sensitive atmospheric scanning capability of the James Webb Telescope, a series of clear and undeniable traces of oxygen have now been detected in the atmosphere of a very distant and remote exoplanet. This new and unexpected discovery is now being considered to be an extremely and incredibly critical piece of data in terms of the very real and possible prospect of the existence of life in the entire universe. This is because the very presence of a significant amount of free and uncombined oxygen in the atmosphere of a planet typically and strongly indicates the very real and possible existence of a series of ongoing and active biological processes that are very similar to the process of photosynthesis that we see here on our own Earth. Although this is not yet considered to be direct and definitive evidence of the existence of life, it is now being considered to be one of the strongest and most compelling clues that is pointing to the very real and possible existence of life in the entire universe. In addition to the presence of oxygen, a series of other and various vital and essential molecules, such as water vapor and carbon dioxide, were also detected in the atmosphere of this particular and unique planet. The various and detailed data that has now been obtained by the James Webb Telescope on the distant and remote galaxies, on the mysterious and powerful dark energy, and on the wide and extensive distribution of matter, have now begun to provide us with a series of important and significant clues about how the entire universe will eventually and ultimately end. In particular, the new and precise observations that are now showing that the most distant and remote galaxies are rapidly and dramatically moving away from each other have now revealed that the very expansion of the entire universe is not, in fact, slowing down, but that it is actually accelerating over time. This new and unexpected finding has now led to the very real and possible prospect of the Big Rip theory being seriously and widely reconsidered in the entire scientific community. According to this particular and dramatic theory, the mysterious and powerful dark energy could eventually and ultimately stretch the very fabric of the entire universe to the very point where it is able to tear apart the distant and remote galaxies, the various and different stars, and even the very atoms themselves in a very catastrophic and final process. The James Webb Telescope has now documented a series of highly detailed and completely unexpected events at a level that has never before been recorded by any of the previous and less powerful telescopes. while it was observing two large and massive galaxies that were in the very process of a powerful and dramatic collision. These particular and unique collisions were not just merely the simple and straightforward merging of two different and separate galaxies. A series of extraordinary and complex processes, such as the powerful and dynamic interstellar gas flows, the sudden and dramatic bursts of star births, the chaotic and powerful magnetic field collisions, and even the powerful and dynamic interactions that were occurring between the supermassive black holes, were all detected and recorded. It was now understood that such powerful and dramatic collisions are able to affect the wide and extensive distribution of matter, and the long and complex evolutionary process in the galaxies much more than had ever been previously thought. The powerful and highly sensitive infrared observations that have been made by Webb have now revealed a series of massive and extensive hydrogen gas streams that are flowing between the two colliding galaxies, like a series of powerful and dynamic rivers. A series of new and highly detailed observations that have been made by the James Webb Space Telescope of the distant and massive galaxy clusters have now revealed the very real and possible existence of a series of previously unknown and highly dense regions that are located within these massive and extensive structures, which could now be accurately and properly described as being a series of cosmic cities. In these particular and unique regions, the various and different galaxies are all clustered together in a very high density and closely packed pattern. However, what is truly and utterly astonishing is the fact that the rates of star formation in these particular and clustered areas have now reached a series of extraordinary and unprecedented levels. And the levels of energy that are being emitted are also unexpectedly and dramatically high. The new and precise spectral analyses that have been conducted by Webb have now shown that these cosmic cities are not only physically very close to each other, but that they are also strongly and powerfully interacting with each other in terms of the constant and dynamic flow of their matter, the high and intense intensity of their radiation, and the widespread and extensive transfer of their gas. Some of the various and different cosmic anomalies that have now been recorded by the James Webb Telescope could now bring some of humanity's greatest and most long-held dreams of interstellar travel to a very real and possible scientific and tangible foundation. The high and intense energy density and the significant and dramatic matter distortion that have now been observed in some of the most distant and remote regions of space by the telescope now strongly suggest that the very fabric of space-time is operating in a very different and unique structure. This could now indicate the very real and possible existence of a type of natural and occurring space-time tunnel, which is more commonly and widely known as a wormhole. The various and different differences in the various and different angles at which the light is able to refract, the various and different anomalies that have been observed in the transfer of energy, and the various and different distortions that have been observed in the density of the matter in these particular and unique regions are now all exhibiting a form of behavior that is completely and utterly defying all of the known and well-understood laws of classical physics. If these particular and unique regions are, in fact, able to truly and actually transport matter or even spacecraft at speeds that are faster than the very speed of light from one particular and unique place to another, then this would undoubtedly be a major and significant turning point in the entire history of humanity. The various and different findings that have now been revealed by the James Webb Space Telescope are now carrying a series of meanings that are so incredibly profound and significant that they will undoubtedly shake not only the entire scientific world, but also all of humanity. The various and different secrets that have been hidden in the dark and mysterious corners of the entire universe are now gradually and slowly coming to light. And we are only at the very beginning of all of these magnificent and groundbreaking discoveries. Perhaps the very act of looking through the powerful and unblinking lens of Webb is actually the very act of looking at ourselves. It is now reminding us of where we have come from, of where we are now going, and of how incredibly small, and yet how incredibly meaningful we are in this vast and endless infinity. Every single and individual step that has been taken in the long and ongoing pursuit of the unknown is now bringing us not only much closer to the distant and remote stars, but also a little bit closer to ourselves. And maybe, just maybe, one day, the various and different images that we are now seeing today will be the very first lines of a new and great era that we will all one day look back on and say, that's when it all began.